Good morning, students. Welcome to our online classes. Part of our AC motors. We are going to learn in this class very interesting topic, open circuit test and short circuit test, what we have done on single phase transformer. Similarly, we are going to conduct no load test and short circuit test on a 3-phase induction motor. Before that, happy Pongal to everyone. As you know that today topic is regarding to 5th semester AC motors C18 EE 503 3-phase induction motors, and courtesy to all original authors who are published their pictures, videos, and heartfully thanks to them. Now, what are the aim of today's class is to find the parameters of induction motors. You already learned that induction motor is a very good, powerful and a constant running motor, and cheap and best, rugged, and we have the plenty of advantages as compared to the DC motors and synchronous motors. Similar to the transformers, induction motor also has a stator winding and rotor winding. Stator winding, at the time of manufactured itself, they inserted in 3-phase distributed winding. You can observe this winding in this case. This, what is the value of these winding values? I want to know that. What is the resistance, the total resistance R1 and R2, X1 and X2. This R1 or X1 is regarding to the primary one, and R2 X2 is regarding to the rotor 1 values. At the same time, the no load current, that is equal to I0, so used to pass through the I, that is equal to R0 and X0 components, where this is required to establish the magnetic field, and another is the established magnetic field has to work. That purpose we are going to use this R0 X0. These are the values. If I know of a induction motor, I can easily find the performance of these induction motors. We have seen, we have calculated what is the current of induction motor, what is the torque of induction motor, what is the maximum torque, what is the efficiency, what is the slip, everything we know with mathematically. At the same time, I want to know that this motor performance values based on graphical method. That is why, so induction motor has a circle diagram. One is a diagram which will tells its the performance values at any given load. To draw the circle diagram, we required these components. How we are going to get these components with? So, at the manufacturer itself, they will measure and they will print it on nameplates or in booklets. Now I want to know that what are the parameters of induction motors which plays a vital role to know the performance of induction motor. Okay. So, in this class we are concentrate on the main practical test on a 3-phase induction motor, whether it may be slip ring induction motor or squirrel cage induction motor. Okay. So, let us see one by one what is these tests, how to do this test. Dear students, please remember these tests are everyone has to do in our laboratory. That is why please keep observe what is the procedure, what are the precautions you have to take before starting the experiment, during the experiment and completion of the experiment, what are the precautions you have to take it, and what are the readings, how the equipments, how the tools used in a good manner. Okay. So, very easy test. So, as already you have the good experienced in single phase transformer where you have find R naught, X naught, Z naught 1 in transformer by conducting NoLoad open circuit test and short circuit test on a single phase transformer. Same rules we are going to apply here also, because here the primary act as a stator winding and the rotor act as a secondary winding. The procedure is same. In OC test, open circuit test in single phase transformer equivalent to the no load test on 3-phase induction motor. That means the rotor is rotated freely without any load. The belt which is connected to the shaft should be very loose. So, during this process it acts as a no load test similar to the open circuit test in a single phase transformer. And in second case, the transformer secondary is short circuited and we are going to give the reduced voltage to the primary such a way that it will draw the short rated current in the primary winding with the help of single phase variac. That means, in first case in open circuit test, the OC test, so we are given supply to the primary winding with the help of auto transformer up to rated voltage of transformer. In second case, in short circuit condition, we are going to give the rated current of transformer. Similar the process we are going to give in this case also, but here we are doing 3-phase system. Okay. So, in 3-phase OC circuit, that is the NoLoad test, the rotor is rotates at freely. At that condition, what is the current, what is the voltage, what is the power taken by the motor, we are going to take the readings. These readings are open circuit or no load test readings. In second case, and blocked rotor test. In transformer, in SC test, the secondary is short circuited with a thick wire. Okay. So, you know that there is one conditions in transformer. What are the conditions you have observed in transformer? The open circuit test, that is a no load test, should be conducted on LV side. HV side is a open circuited. Okay. So, in short SC test, we are going to conduct, the power is given to the HV side, LV side is open in short circuit test. But here there is no shifting of the secondary supply and primary side supply. Always in motors we are going to give the supply in stator side only, that is equal to the primary side. Whereas in transformers, as per our convenience, as per the rating of this transformers, always open circuit, that is a no load test conducted on LV side and short circuit test conducted on HV side. You have the good experience on transformers. Similarly, in this case, we always no load test and black rotor test are conducting on primary, that is the stator side only. Don't confuse. Okay, here is a relax. But you have to remember that in case of no load test, you have to give the rated voltage to the motor. Then the motor will run at its normal speed without any load. At that condition, whatever the power is taken from the supply, that is equal W naught, that is the sum of the two wattmeters W1 and W2. In this case, we are going to use the 2 wattmeter methods, and one voltmeter is connected across the 2 lines and one ammeter is connected in series to the one phase. Okay, and in short circuit, the black rotor test, second case, the rotor is blacked with the help of the belt. That means the rotor unable to rotate. So, such a way that we tighten the springs. Initially, we are tightened the rotor, it is not rotating at any stage, it is blacked, it is a standstill condition, that means it is a rotor speed is 0, such a way that your belt is tightened. Now, in this case, now voltage is given 20 to 30% of rated voltage only, such a way that you have to see the rated current is flowing in ammeter. So, in black rotor test, you have to give the rated current to the motor. In no load test, you have to give the rated voltage to the motor. Okay. So, we will see and we will conduct the experiments in laboratory similar to this processor. Okay. So, let us see this one. Now, you can see here, this is a single phase transformer. So, what is happen? We are going to conduct the tests. Okay. So, what are the tests we are going to conduct? This is a transformer. We are going to conduct the OC test, open circuit test, and SC test, short circuit test on transformer. Similar to here, this is the primary, this is the secondary. Okay. For example, this is a LV, this is a HV, high voltage winding. For example, this transformer, maybe you take it 230 volts by 110 volts transformer. For example, 2 kVA transformer. Okay. So, that means LV, what is the LV? 110 volts. Here 110 volts, this side, this is a 230 volts. Okay. So, now, what is happen in OC test? We are given the operators, this is a 3-phase single phase variac here, and meters, ammeters and voltmeters and wattmeters is given to the this primary side. Okay. Now, this is open circuit at secondary. In this case, we are going to give the rated voltage. Rated voltage we are going to give. What is the rated voltage? 110 volts. Slowly vary the variac, and dear students, I recall what we have done in SCOC test on single phase transformer. This can be useful to understand clearly in our 3-phase induction motor. Okay. Now, what is happen here? So, give the connections as per the circuit diagram. Before giving the connection diagram, now you have to remember that This opens are, this is the HV side, this should be open, there is no load connected here, and HV side given the voltmeter, ammeter and wattmeter in such a position with the help of the variac, single phase variac. Now initially give the voltage to the primary in steps slowly up to 110 volts. Then take the what is the voltmeter reading. Okay. So, what is the voltmeter reading? You can take that is equal V0, and you take the ammeter reading I0, and you take the wattmeter reading W0. These are the no load, that means open circuit test results. So, what we have done? So, we have given the 110 volts to the primary. At that condition, what are the readings of voltmeter, ammeter, wattmeter we have taken? This is a OC test. Okay. Here, in this case also, in our induction motor, now the OC test, instead of OC test, that is equal to no load test. No load test. Okay. Now it has a primary. Okay. So, primary connected the one ammeter and one voltmeter and wattmeters. Okay. This is a 3-phase, you connect the wattmeters to the variac here. Okay. Now this is a variac. So, this secondary is nothing but a rotor. Here this is a open, there is no connected electrical load in the secondary side, that is the HV side. Here there is no mechanical load on our rotor. Okay. Now primary is the this stator and the secondary is the our rotor. Okay. Now supply is given to the here primary, that is the LV side voltage. Here the supply is given to the stator winding. Okay. Now what to do in this case also? So, you are going to give the rated voltage of motor. So, you know the nameplate details, that there is a 410 volts rated voltage, and it may be current, may be having the, for example, 7.6 amperes full load current. Okay. It may be, for example, you take the 5 HP motor, it is a rated value given. Now, in this case, first case similar to the OC test. Now, you take the, that is equal no load test. Now, in this case, give the rated voltage to the stator with help of 3-phase variac. Okay. Now, give the, what is the rated voltage? 410 volts. Give it 410 volts to the stator with help of variac, wind slowly. Once the rated voltage indicated by the voltmeter, then take the voltmeter reading, that is called W0, and ammeter reading I0, and W1 plus W2, that is equal to power. Okay. So, this is the no load test on induction motor. Okay. Now, coming to the, so whatever you are calculated here, this SC test, this OC test in our transformer. From this OC test, we are going to calculate what is the parameter R0 and X0 values. Okay. At the same time, core losses. Okay. From the OC test, our aim is to find the no load losses, friction and windage losses, core losses, copper losses of stator, and no load power factor R0, X0 we are going to calculate in no load test on a transformer, that is the induction motor. Okay. This is similar to the ear also. So, in transformer there is no friction and windage losses. Similar the no load losses and copper, stator copper losses, and that is the primary copper losses and secondary copper losses, and power factor under no load condition, R naught and X naught are the parameters we found in case of single phase transformer. Similarly, we are going to calculate with the help of the no load test. So, what is the no load losses, what is the friction and windage losses, what is the core losses, what is the copper losses of stator and rotor, and no load, power factor, R naught, X naught we are going to calculate with the help of these readings only. Okay. So, these are the similarity between the OC test and no load test. We will do with the help of our diagrams step by step. So, this is at a glance I am going to give the some brief. Okay. Now, coming to the SC test. So, how we are going to calculate the SC test? So, in SC test, so here what is that? You are going to connect to the HV side here, this is connected to the LV side. Okay. So, whatever the connections is given here, so with help of the same variac and ammeter and voltmeter and wattmeters, similar connections we are going to given here. Okay. Here H, what is the HV side here? Now, this is a 230 volts, this is the 110 volts. Here you are going to connect one thick wire here, short circuited. Okay. This is a short SC test on single phase transformer, similar to our black rotor test. So, blacked, that is the rotor is blacked rotor test, similar to the SC test. Now, what is the SC test? In this case, I am going to give the rated current only. That means only 20 to 30% of rated voltage. I am going to apply here, not full voltage. If you are given the full voltage to this transformer, it will burn. So, please remember these precautions. Okay. So, you have to give the rated current by observing voltmeter and ammeter. So, when the current is flowing in ammeter, rated current, at that condition you can observe what is the voltage in the voltmeter, that is nearly 20 to 30% only. Okay. Now, in this case you have to observe only ammeter in SC test. Similarly, here you are going to give the similar experiments, the same thing. So, you are going to the ammeter, you are going to the voltmeter, and you are going to the W1 and you are going to the W2. So, with help of the 3-phase variac, similar to this one, same process. Okay. Now, in this case what will happen? The rotor is blocked, it is tightened. So, by using the belt. So, rotor unable to rotate in the rotor, tightened, blocked it. Now, in this case, similarly, whatever the current is given to this is the HV side with help of the variac very slowly, and once it reaches its rated current on observing in ammeter, then stop the variation of variac, then wait for 5 seconds, then take the what is the voltmeter reading VSC, what is the ammeter reading ISC, and what is the wattmeter reading WSC. These 3 values we are going to take in short circuit test on a single phase transformer. Okay. Now, after that completion, so you have to take the reading quickly because short circuit condition, rated current. Then after taking the readings, come to the 0 voltage position, then open the ICDP switch. Okay. So, this is a short circuit test on a single phase transformer. Similarly, we are going to conduct similar test in our 3-phase induction motor. Now, what is happened? The rotor is blocked, the stator side we are given the all parameters, operators, 1 voltmeter, 1 ammeter and 2 wattmeters W1, W2. We are connected here to know the voltage, current and power respectively. Now with the help of our variac, slowly give the voltage, slowly, very slowly, by observing ammeter. Once ammeter shows a rated current, then stop the variac. At that condition, you take the what is the voltmeter reading VSC, or we can take the VB black rotor test, short circuit test, and ISC and W1 plus W2 readings. After taking these readings and come to the 0 position with help of variac and open the ICTP switch. Okay. So, these are the similarity between the short circuit test and black rotor test. Okay. From this one, we are going to calculate what is the parameters. What are the parameters we are going to calculate? So, in this case, in rotor test, we are going to calculate. So, in short circuit, we are going to calculate the R01 and X01 refer to the primary side. Similarly, here also we are going to calculate R01 and X01 we are going to calculate. Okay. So, these are the similarity between the open circuit test and NoLoad test, short circuit test and black rotor test between transformer and induction motor. Okay. So, these are the similarities. Now, you can, after knowing these values, so we are going to calculate the equivalent circuit diagram. Okay. What is the equivalent circuit diagram? You know that very well. I want to know that equivalent circuit diagram. Already we have seen equivalent circuit diagrams of induction motor. Now, I want to know that from this test, what is the test? What is the that is the NoLoad test. Okay, that is the one is the NoLoad test, and is the black rotor test. Black rotor test. From NoLoad test, we are going to calculate this is R0 and X0 values, these parameters. Okay. At the same time, so what is the NoLoad losses, friction and windage losses, core losses, copper losses of stator, and NoLoad power factor, and R0 X0 we are going to calculate in this NoLoad test on a induction motor. Okay. From black rotor test, we are going to calculate these values. What are the values? This value and this value and this value, these values. So, this one that is equal to R01 refer to the primary side. What is R01? R1 plus R2 dash. Similarly, so X01 refer to primary side, X0 plus X2 dash. These parameters I am going to find in a induction motor. Okay. So, here this is from the black rotor test, I am going to these values, and from NoLoad test I am going to calculate these values. Okay. So, let us do one by one. Dear students, these tests are very essential to all our electrical students. If you are going to any industry, the motor is giving some trouble, then you are going to conduct what is happened inside, what is its efficiency. So, you are able to know it. That is why, so you should know what is the procedure of NoLoad test and black rotor test. Okay. At the same time, you are able to find its parameters R0 and X0 and R01 X01, which plays a vital role to find the performance of induction motors. Okay. So, do not panic, we will see one by one. This is two experiments we are going to conduct in our laboratory. So, here I think it may be it covers the 4 experiments. One experiment is the NoLoad test on squirrel cage motor, NoLoad test on slip ring induction motor, and black rotor test on squirrel cage induction motor and black rotor test on slip ring induction motor. That means you are going to do the 4 experiments. From that experiment you are going to find these parameters, and from these parameters you are going to draw the circle diagram. What is the circle diagram? We will see later. So, what are the mathematical equations? We are going to prove it. We find it, these values, what is the maximum torque, what is the efficiency, everything, whatever we are going to calculate it in mathematical with the help of the equations, same values we are going to get it on a graphical method. That graphical method, that is a circle diagram. This circle diagram can be drawn with the help of NoLoad test and black rotor test. These 2 experiment readings will help to draw the circle diagram. From the circle diagram we can find what is the no load power factor, what is the power factor at any given load, what is the torque, what is the maximum torque, everything, what are the values we have found with the help of these equations. Same values can be obtained with just by taking the lengths in a graphical method. So, how to draw the circle diagram we will see in next classes. Okay. I think you have some idea on no load test and black rotor test. What is the purpose? So, to know the no load test losses and friction and windage losses, core losses, copper losses of stator and no load power factor and R naught and X naught with the help of no load test. And the purpose of black rotor test is to find that the parameters of R1 and X2, R1 and X1 and R2 and X2, that is equal Z01, that is called R01 plus J of X01, refer to the primary side or sometimes refer to the secondary side also. Okay. So, we will see that one. Now, you can see it. In last class, we have seen the no load test in clearly also. Okay. Clearly, we have seen the no load test. Now, in this class, we are going to concentrate on block rotor test and stator resistance test. Okay. So, how to do this experiment? I will explain once again. Okay. So, how to this one? You can do it, you can see it. Okay. So, we will see the once again this one test. Okay. Now, so what is the no load test? No load test. Dear students, because this test is you are going to perform in laboratory, that is why I am concentrating once again. Okay. So, you can see it how to do this experiment. Now, no load test, what is happened? So, here is our motor and is connected here based, and we have the rotor also, and rotor has connected with belt here, and we connected the one spring balances. From this one I am connected to this one with the help of adjustable spring tension adjustable. Okay. So, this is the S1 spring, this is the S2. Rotor is connected with the belt. Okay. It's the load belt. Through the springs it will show the load on cages. This is the adjustable springs. Now, I connected this from terminal box is connected to this one phase, this another phase is connected to this phase. Okay. Now, what is happened here? Connected the R phase, Y phase and V phase, okay, B phase through the IC TP switch, Similarly, you are going to connect the same thing here. Okay, you connected the 3-phase variac. 3-phase variac. So this is the ICTP switch. ICTP iron clad triple pole switch. Okay, so this switch, this is the R phase, Y phase, B phase. Okay, now 3-phase supply is the 3-phase supply is given to this one. 3-phase 400 volts, 50 H. Now 3-phase variac. Okay, variac. Now here connected output of this variac is connected such a way that I connected the one ammeter here and is connected one wattmeter. Now connected one voltmeter across these two lines and connected to this one, and here also I am connected one wattmeter here, CC coil, and it is connected to the PC coil to this one. Okay, so similarly you connect this one. Now what is happened? So this is connected, this one, and this is connected here. Okay, now you know that terminology also. So what is happened? This is a voltmeter, that is called V, it will indicates. This is a current indicates. This is a W1 and this is the W2. Okay, this meter is connected. How to connect the voltmeter and ammeters, you know. So here we are going to, we know that to know the power in a 3-phase system by using the single wattmeter method, 2 wattmeter methods and 3 wattmeter methods. Okay, so very familiar is the 2 wattmeter method. So it will simply gives the values with help of the whether it is a balanced or unbalanced condition. Okay, so here these connections are given as per circuit diagram. This is a connection diagram. Okay, so what are the precautions before start the experiment? Now you take it. So we take it, what is happened? R phase, Y phase. What is the precautions? This belt should be loose. So here the rotor belt should be very loose. No load on rotor. Now you know that M, L, C, V is connected. Here also M, L, C, V, the terminals wattmeter connected. And here is all meters are the AC meters, MI meters, voltmeter MI, ammeter MI. So this voltmeter and ammeter values are based on the motor ratings. Okay, so here for example the motor nameplate details we can take it. So suppose voltage of this motor is equal to 410 volts 3-phase supply, and the current is, for example, you take the 8.67 amperes, for example, it may be 5 HP. Let us assume. That means rated voltage is 410 volts and rated current is 8.67 amperes. For example, these are the given nameplate details values for a 3-phase 5 HP motor, squirrel cage induction motor. Okay, so these are the given nameplate details, and we connected our equipments, that is the voltmeter, ammeter, wattmeters in such a way that now this is ready to conduct no load test on 3-phase induction motor. Okay, now before that one, so you know the voltmeter and ammeter, wattmeter connections. Okay, so we are very familiar. So before that one, I will once again recall how to connect this one. So what is happened here? The wattmeter. So ammeter always connected in series only. Okay, ammeter connect. For example, here what is the rated current? 6.7 amperes. 6.7. For example, what is the current? It's given 8.67. Okay, is a 8 point is given 8.67 amperes is given. So anyway, you have to use a 0 to 10 amperes ammeter and this is the AC, you can use the MI. Okay, you can use the moving iron instrument. This for ammeter. And voltmeter, you take the voltmeter, you connected the between the two phases. You can take you connect the R phase or Y phase, B phase, any phase you connected in series. Now here connected for example, you connect the between the two lines, whether it is R phase, Y phase, B phase, or any phase, two phases. Then you connect it. So here what is the voltage? So voltage is the 410 volts. So that's why you connect this is equal up to 500 volts range 0 to, and what is the type? Type is the moving iron AC. These are the voltmeter values. Now coming to the wattmeters. Okay, this is a ammeter value, this is a voltmeter values, and next is the power. Voltage purpose, current purpose, and power purpose. So power can be measured. The power can be measured with the help of single wattmeters for the balanced load, power in three-phase circuit can be found by single wattmeter method for the balanced condition load and 2 wattmeters method for balanced and unbalanced condition and 3 wattmeter methods in unbalanced condition. Okay. So, among these all, this I prefer to the 2 wattmeter method in our experiment. So, in 2 wattmeter methods, what will happen? One wattmeter is a W1, another wattmeter is a W2. So, I want the power, that means the power is equal, total input power is equal W1 plus W2. And already we know that what is the role of this W1, W2. You already learned it in previous classes. What is happen? This W1, W2 will give the readings such a way that one meter may be positive, another meter may be 0, and another meter may be negative, another meter may be positive. So, sometimes both will show the same readings. These are the values already you have seen in second year level. Okay. So, what is happen? For example, take the two, or don't confuse. What is happen here? The connection, how we are going to give the connections? So, simply it is a wattmeter consists of, what it consists? So, 4 terminals. Okay. So, that is a M, L, C, V. So, ML, what is the ML? ML is a CC coil. It has a very thick, less number of turns, whereas the PC coil is a more number of turns, very thin lines. Okay. So, this is the CV. So, what is the MLCV? That means the CC, this is represented by the CC coil, the current coil. What is the terminals? M, and this is the L. And what is the CV? So, here connected some resistance, some inductance values. Oh, now it is connected. C means common, V is the another line voltage. Okay. So, these are the connections. So, what you are going to do? So, you connect the CC coil in series. Okay. Always connect to the CC coil in series, that will measure the load current, and PC coil is connected across the 2 terminals. That is, suppose you connected this one shorted C common point, and this is the M, and this is the L, and this is connected to the another line. Suppose for example, you connect to the R phase, you connect to the Y phase. Between the R and Y phase, it will measure the voltage by PC coil, pressure coil. This is the current coil. Okay. You know that how to connect the wattmeter in a laboratory. Okay. These are this one. And sometimes there is a possible to multi-range wattmeters. Here what is happen? 4 terminals. So, you are very lucky. So, no need to multiply with the multiplication factor. Then how to calculate if the more number of the terminals on a meter. So, what to do? So, in that case, for example, you take the wattmeter. I am giving the information, dear students. So, don't confuse it. It can useful wherever you are going to use the wattmeters in different ranges. So what is happened here? Terminals 1, 2, 3, 4, 5, and there is a settings also in this here. Okay, so now what is happened? This is a M, this is a L, this is a C, this is a, for example, you can take the V1 and V2. And this current settings here, this you can say these are the, here also where there is a one clips, you can observe this is the clips here connected here. So in this case you have to remember that. So here this range is known as voltage range. That means one you can connect V1 or V2 as per your requirement. For example, V1 I want to connect it. What is the correct connection? Is the, for example, 230 volts V1, and V2 I connected the 500 volts. For single phase I can connect to the 230 volts. For the 3 phase I can connect to the 500 volts. There is a options in this case. Okay, at the time, so here this area is known as a current setting. What is the meaning of the current setting? Here what is happened? So this wattmeter can be used for example 5 by 10. That means it can be used up to the 5 amperes, or if required I can use the up to the 10 amperes. Such a way that I can set the current range also. So how we are going to connect it? You can observe here there is a 2 clips. Okay, so there is a clips is adjustably connected such a way that this one. Now what is happened? This is a high range. So if you are going, just remember that. So it's similar to the H, high range. So that means high means, so what is the current here? 10 amperes. You can use the high range is the 10 amperes. For example, if you connected these 2 terminals such a way that, so this is connected such a way that, and this is connected in such a way that. Now what will happen? This is the low range, L, simple L, this is the L, okay, low range. What is the low range is given? Here 5 by 10, 5 is the 5 amperes. Dear students, so it is not fixed one. Sometimes it will give the 10 amps by 20 amps. What is the low range? 10 amperes. Now we can see the low range is the 10 amperes in this case, and 20 amperes you can take the 20 amperes. So you observe inside the meters given. Okay, so this is a current setting. If you are connected parallel, there is a high range. If you are connected in series, you get this a low range. Okay, so based on this physical connection, you calculate the multiplication factor. What is the multiplication factor? MF you are going to calculate. Okay, so you can see here. For example, I connected here. You can see here. Green color you can. Okay, now what is happened? I connect supply is given to the M, and this is connected to the L motor. Okay, so supply is connected input, and here M and C is shorted. Now shorted. CC coil, this is the CC coil connected meter, and M and C is connected. This is one, and I connected the for 3-phase induction motor. I can take the V2 is the another phase. Here is connected the R phase. You connected the Y phase, for example. Over. Now, so our motor is, what is the rating of our motor? 6, that is the 8.77. 8. What is the value? So ammeter reading is the this is the 8.67. So here 8.67, that's why I am going to connect to the high range. So this is a 10 amps, I can take the 10 amperes. So I connect to the parallel, this one. So now what is happened? This I set it. Voltage is equal to V2, that is equal to 500 volts I connected, and current setting is equal to high range, that is the high range that is connected the 10 amps. I connect physically, I connected. At the same time, if you are observing the full scale reading in the meter. For example, so from this readings the 0 to 3000. For example, we take the 3000 maximum reading watts. What is the full scale deflection? Full scale reading, that is a reading is given on the meter, that is equal 0 to 3000 watts. So, these are the given values. From this I am going to calculate the MF. So, now what is the MF? Multiplication factor is equal to, so voltage range, okay, voltage range into current setting, okay, divided by full scale deflection, full scale reading. You can take the full scale reading. So, this is the formula, voltage range into current setting divided by full scale reading will give the multiplication factor. What is the voltage range, sir? So, this voltage range is nothing but whether you are connected the V1 or V2. Okay, that is the voltage range. There is a two ranges. One is the voltage range, V1 is the 230 volts, V2 is the 500 range. So, where you are connected the physically on terminals, whether you are connected to V1 or V2. So, in this case I connected the V2. So, that is the voltage. What is the voltage range? This is the voltage range 500. I can take the this value equal to the voltage range equal to the 500 physically connected the V2 into current setting. So, what is the current setting? So, here I connected the parallel. So, here current setting is the whether it is connected parallel or series. Now, which connection I have given here? I connected the range 0 to 10 amps I taken here. So, my motor reading is the 8.67, that is why I connected the 10 amperes. So, that is why I connected the parallel. So, now I take the range. What is the high range? 10. So, in this case high range is the 10 amperes. I can take the this current. What is the current setting is the I set it to the 10 amperes divided by full scale reading. What is the maximum reading from 0 to this reading? What is that one? So, this is a 3000 watts. Okay, I can give the full scale reading is the 3000 value. So, this is a MF. Now, simply what is a 0? This is a 0, 0, 0, 0, 0. What is the value? 5 by 3. So, this is a MF. Okay. So, what is the value? That is the, that means the 3 ones are 3. Okay. 3 6 are 18. Okay. So, 6 6 6. This is a MF calculation. So, MF multiplication factor of wattmeter is equal to 1.67. That means what is the meaning this one? So, for example, if our wattmeter once I connected to this wattmeter, for example, W1 is connected, it is showing the value of, for example, 40 watts. Deflection torque is showing the 40 watts on scale. Now, what is the actual value? This is the reading on W1. W1 is showing the 40 watts. But what is the actual value? So, actual value is equal to the W1 into MF. You have to multiply. So, what is the W1? 40 watts. Okay. What is the multiplication factor? We got it. So, we have got it 1.67. We multiply 1.67. Then I am going to get it. This is the actual value. Okay. So, what is the value here? Now, what is this value? The 40 into 1.66, that is the 5 by 3 we got it. Okay, na? Now, this is equal to 200 by 3. So, we are going to 3 ones are 3, 3 6 are 18 and 18 means what is the value? 2, that is a 2, 6 and 7. Okay, so we are going to a 66 point something value, we are going to get it. Okay, so this is the actual value. Instead of, if you take the 40 watts, it is a wrong. So what is the value? 66 watts is a correct value. So dear students, whenever you are going to use the multi-range wattmeter, then you take the reading of meter into multiply with MF. So most of the standard meters will give the directly MF on a diagram. You take that one, otherwise you calculate similar to the this one method. Okay, this is a W1 reading. Similarly, W2 also, if it is a W2 4 terminals, no problem. If multi terminals, similarly you calculate the is a MF of W2 also, such a way that we are going to connect the wattmeter also. Okay, now we have seen the how to connect the voltmeter, we are how to connect the ammeter, and how to connect the wattmeters also we have seen. And at the same time, please remember, so two wattmeters here, one is the W1 and W2. So these are the two wattmeters will give the readings in three-phase circuits. Before that one, so remember that what is happened, for example, the phase angle. So at phi is equal 0 degrees, and W1 will shows what is the power factor. So here the power factor is equal, W1 will shows and W2 will shows. So at this angle, you can take the here also power factor also. At power factor at 0 cos phi, okay, cos phi, cos 0 is equal to 1, that is equal power factor 1. And power factor at 60 degrees, for example, what is a cos 60? Cos 60 is equal to exactly 0.5 of the value, and power factor is equal to say 90 degrees, then cos 90 is equal to 0. That means 1.5 0 condition. At the power factor condition, our wattmeters will show its readings in such a way that one is a positive, another is a negative, another is a 0, another is a different values. Okay, so already you have seen what you have seen. So here two wattmeters W1 and W2, what is the its behavior at a different power factor angles. Okay, now the power factor is equal 1 at that condition. So what is happen? So here the W1 will shows the positive value only, and W2 also show the positive value, but these both are equal at power factor is equal 1. At that condition, W1 is equal W2. Both are in positive and both are equal. Two wattmeters will show the equal readings and positive. Don't confuse. Okay, at that condition you have to remember that the power factor is UPF. If the power factor is equal to 0.5 exactly, okay, that's the 0.5 lagging. At that condition, what will shows, so one W1 indicates, one of the wattmeter indicates the positive value, and another will shows the 0 reading. That means it is not working. So it is not failure to read the reading, but at that condition the wattmeter W2, one of the wattmeter will shows the 0 reading and another wattmeter will shows the full values, that is the positive value. That what is the total power? Total power is equal P is equal W1 plus W2, that is equal whatever the 1 meter shows, that is this one. In this case, what is the power? Power is equal W1 plus W2. Both readings will give the full at power factor 1. At power factor 0.5, that is the power factor. So at exactly 0.5 lagging, at that condition, one wattmeter will show a positive value and another meter will show the 0 value. For example, at the power factor is equal 0, that means the phase angle between the voltage and current is equal 90 degrees. At that condition, what will shows? One wattmeter W1 shows a positive reading and W2 will shows the negative readings. It will goes to the reverse direction. That means the wattmeter, this W1 indicates this direction, deflecting torque, and whereas a W2, okay, W2 will shows the reading this direction, that is this direction, okay, negative value. What to do negative value? Already I have explained. Okay, so positive value and negative value. So W1 is equal to W2. At that condition, what is the power? The power is equal to 0. W1 plus W2 is equal to 0. Exactly will shows the readings but in opposite directions. So these are basic things already you have learned in second year level. So based on this knowledge, you have to perform the experiment. Don't panic. 1 meter showing the reverse direction, 1 meter showing the 0 direction, 1 meter showing the positive direction, and both meters will show the equal values. That is based on the power factors. Okay, the power factor of the motor. This power factor will change from no load to full load. So during, if the power factor changes, the readings of the meters also changes. The changes, what are the changes we have seen just now. Okay, these are the basic things, dear students, every student has to know before going to the our experiments. Okay, so these are the basic things before going to experiment. Okay, so let us continue our experiments where we are. So 1 hour. Okay, so we will see now. Now this we have seen. Okay, now we have seen. So what are the precautions we have to take while starting the experiment? Okay, so how now we given connection is given such a way that as per circuit diagram. How to do this experiment? Okay, that is also now. So based on this basic idea, now I am going to conduct the experiment. This is the experiment I am going to conduct. Okay, so now how to conduct this experiment? Now I given the this circuit diagram, and what is the procedure? First one procedure is equal to here precautions. Before starting the experiment, the belt should be loose, belt, that means no load, belt should be loose. Second one, all connections should be tight and variac should be at 0 reading. Variac, you check it, variac at 0 reading, 0 voltage reading, and ICTP should be open circuit condition. Okay, IC, iron clear triple pole switch should be at open condition. These are the precautions before starting the experiment. And at the same time you have to choose it the proper range and proper type, whether it's a MI meters and range is correct or not, 0 to 10 amperes, 0 to 5 amperes, and 0 to, that is the 230 volts, or 0 to 400 volts or 500 volts. You check it, otherwise the meters may be burned. Okay, these are the precautions. Now during the experiment, what are the precautions? During the experiment, you take it, the variac should be slowly raised by observing voltmeters in case of no load test. By observing voltmeter, slowly increase the variac terminal. Once the variac shows near rated voltage, that is called 410 volts in voltmeter, then stop the variation. That is the precautions. Now after, before closing the experiment, what are the precautions you have to take it? That is equal to, once you are going to close it, slowly rotate in anti-clockwise direction such a way that the voltage of variac should be 0 volts. Then open the IC TP switch, just like the back procedure. Don't open ICTP switch when the variac is full load voltages. Okay, it will give us some spark. So, these are the precautions you have to observe while doing the experiment. Okay, these are the precautions. Now, what is the procedure? Now, I want to do the experiment. So, how to do this experiment? So, we will see. Okay. So, now we can take this one. This is the processor. I want the processor. Now, what is the procedure first? Give the connections. I close the ICTP switch. Okay, ICTP switch. Close this ICTP switch. Okay, close the ICTP switch. Then second position, slowly vary the variac, 3-phase variac, such a way that give the nearly 70 to 100 volts initially. Then rotor will slowly start rotates. Then stop variation of variac. At that condition, you can observe the ammeter reading. The ammeter will shows the maximum current, because the starting current of induction motor is equal to, so 5 to 7 times of full load current. Okay. So, it initially will draw the more current. You can observe in ammeter. Okay. Once rotor pickup due to the back EMF, there is no back EMF in the rotor. Once the rotor starts rotates, then back EMF develops, it opposes the applied voltage, then automatically current will comes to normal position. Then at the same time, once the rotor rotates, it is near to its rated RPM, then current comes to back to the normal value, low value. You can observe this all things in meters. Okay. Once ammeter shows the minimum current, then increase the variac. Now, increase this variac up to rated voltage. What is the rated voltage? 410. At that condition, the motor is under no load condition, running at steady state condition. At that condition, you take what is the voltmeter reading. Voltmeter the V0, you take it, for example, what is the voltage? 410 volts. What is the ammeter reading? You take the ammeter reading, for example, 1.5 amperes. Then what is the W1? You take it. So, W1 is equal, for example, 40 watts, and W2 you take it, maybe is a 20 watts. Okay. So, these are the readings. Once the power based on the power factor, one of the wattmeter will shows the reverse direction. At that condition, what to do? You have to change the CC coil or PC coil terminals, then you take the reverse of that values. Okay. That is procedure already know. These are the readings from no load test. What we have seen? So, it is the running under normal condition with the rated voltage, with the rated speed. At that condition, what is the voltage? The 410. What is the current? 1.5 amperes. What is the W1? 40 watts. What is the W2? 20 watts. These 4 readings you have to take it. Okay. So, at the same time, you take the speed also. Sometimes we require the speed, rated speed. That is how, for example, 1440 RPM. By using the tachometer, you take the reading. These are the readings required in case of no load test. Okay. So, after taking this test, what to do, we will see in the next class. Okay. So dear students, please stay with another class.